Right. So today we're going to be starting with finding slope given 2 points. So if you're writing these notes by hand, today you're going to title your notes 3.3, and then you're going to write finding slope given 2 points. And this is our second strategy. You can put a number 2 there for finding the slope. So where this idea or this concept comes from is that if you consider 2 points, any 2 points, I've got these green 2 points, these pink 2 points, these purple 2 points. If I were to connect any of these 2 points, what would I be forming? All right, I've created a line every single time. A line can be defined by 2 points being connected. So it would make sense if we're going back to this main idea of slope. Slope is the steepness of a line. We can find slope given a graph, but also if we don't have a picture or a graph, as long as we're given 2 points, we can find the slope between those 2 points. We can find the slope of that line. And so even if we don't have a picture to go off of, we can still find the slope. And that's what we're getting into today. So this is going to be a little bit more algebraic than geometric. Like on Monday, we were working with actual images and pictures of graphs. Today, we're going to be working with pure algebra and a formula for finding this. So if you're taking notes by hand, the next thing that I want you to jot down, and if you're following along with me, the next thing we're going to point out is the slope formula for if you're given 2 points. So that's right here in this purple box. I'm going to leave a little space over here to add a note. Remember, slope is indicated by the letter M. So if you see something M equals, that means slope. And if we're given 2 points, we are going to find slope by using this formula. And it's y2 minus y1 divided by x2 minus x1. In other words, what we're doing, another way to write this short is delta y. That triangle symbol, you may have seen it in science. It means change, the change in values or the difference in values. So we're taking the change in y divided by the change in x. The first misconception that people often have is that they do x divided by y, but for slope formula, it's actually y divided by x. And I'm going to show you exactly why that's the case. Because it matches up with the slope formula we've already been using with rise over run. Remember, rise is a vertical change, so it's our y value. Run is a horizontal change, so it's an x value. So we can see here, if we look back up at this graph, the change in y is really the rise. So for this first point, we have the point 1, 2 here. And the second point, you don't need to do this, just kind of watch. The second point is 1, 2, 3, 4, 1, 2, 3, 4, 4, 4. So if I were to apply this formula to this image, what I'm doing is y2 being my second y value, which is 4, and y1, that's y2, here's y1, is 2. If I'm finding the difference, 4 minus 2, that's 2, which is what I identified as my rise. And then for run, or my change in x, my x value here is 4. And my x value for my first point was 1. 4 minus 1 is 3, which is my run. So these actually completely correspond with one another. And that can maybe help you remember rise over run, rises up and down. That can help you remember why the change in y goes on top, because that's a major thing that people do is they do x over y instead of y over x. So this is the formula that you're going to be using and that you want to commit to memory. You need to get very familiar with that. But now we're going to walk through the steps of how to actually apply this formula. So step 1, and if you're handwriting your notes, make sure you get these down. You must label the points. We're going to label the points x1, y1, and x2, y2. Remember, we're going to be given 2 points. So for that first point, you're going to have your x1 and your y1. And then on the second point that you're given, you're going to have x2, y2. Once you have your points labeled, step 2 is going to be very easy. You're just going to plug them in to the formula. So step 2, plug the values into the formula. Finally, step 3, this is the same exact step that we had when we were graphing. Step 3 is always going to be to write the slope as a simplified fraction. We want to simplify the fraction. So those of you who are writing by hand, you're going to write example, and then you're going to write the point -5, 6 and 7, 2 right here. All right, now we're going to actually apply our steps. Step 1 is I'm going to label the points. This is my first point. That's why I'm labeling the points x1 and y1. On my second point, they have the names x2 and y2. The labeling is really important because the order that you plug these into the slope formula matters a lot. If you get these out of order or plug them into the formula wrong, you're going to get the wrong slope value. So that's why it is important that we're labeling them. Once we have them labeled, we're just going to plug those values into the formula. Remember, the formula is m equals, slope equals, y2 minus y1 divided by x2 minus x1. So besides labeling, another strategy that I want you to use for now, it's going to be a mandatory strategy as we get going. I will kind of leave it up to you, but on the front end, a lot of people make mistakes with the order of plugging these in. So what we're going to do is we're going to draw arrows to help us. So I'm going to draw an arrow from y2 over to y1, showing that this is the direction I'm subtracting. So I'm subtracting 2 minus 6, and that's how I get these values right here. 2 minus 6 goes in the numerator. You must make sure you're subtracting y2 minus y1. And then we also need to do the same thing with the x values. We need to subtract in the same direction. So if I did y2 minus y1, I also must do x2 minus x1. This is the second common mistake that people make. They do y2 minus y1, and then they do x1 minus x2. Their arrows are going opposite. The arrows have to be subtracting in the same direction or else you're going to have an issue. So x2 is 7, and then I have minus -5. You must write minus -5. It's not just 7 minus 5, it's 7 minus -5, which we know minus a negative like this is actually plus. So then you can go add that in, add a plus sign in there to show what we're doing. That is the step right there that if people make a mistake, it usually is right here with plugging in. Now we're just going to do the math. 2 minus 6 is -4. And then 7 plus 5 is 12. So we get -4 over 12. Step 3 says, write the slope as a simplified fraction. That means I need to look at this and ask myself, can this simplify? And in the case of -4 over 12, the answer is yes, I can simplify this. Both the numerator and denominator can be divided by 4. So I'm going to go ahead and do that. -4 divided by 4 is -1 over 12 divided by 4 is 3. So my question to you is, based on our prior learning, what would we expect this line to look like? I didn't have a graph to look at, but based on what we know about slope, I have a slope of -1/3. What could I expect this line to look like? That it will be going down. If we're reading it from left to right, it will be a line that is going down. Specifically, we will be going, for every unit that we go down 1, we'll be going over to the right 3. So that's what our line will look like, something like this. All right, so now we're going to move on to the skills practice portion. For today, we're skipping the table section. We already did the page with graphs. Today, we're going to 3.3 skills practice continued. So if you're doing this on paper, you may just want to draw a line and write 3.3, Skills practice continued, or skills practice today, we're finding slope with 2 points. You want to probably just mark that down somehow. And here are the directions. We're going to find the slope of the line, and then we're going to draw the line, and we're going to kind of verify that we found the slope correctly. So this is skills practice. So I'm going to be doing all the odds with you, and then you'll be on your own to do 8, 10, and 12, and that's what you'll be submitting on Canvas. So first we're going to take a look at number 7, and we're just going to be following the 3 steps that we just learned. So first I'm given 2 points. The first thing that I need to do is label these points. So if this is my first point, then this first x value, this is x1, and then this would be y1. This is my second point, so I'm going to label my coordinates x2 and y2. If you're writing these by hand, just make sure that you have those coordinates written 4, 9, and 1, 6. So now step 1 is done. We've labeled our points. Now we're going to plug them into the slope formula. A reminder that the slope formula m equals y2 minus y1 over x2 minus x1. So as we're using the slope formula, m equals, remember I'm going to draw arrows here to help remind me that I need to subtract in the same direction both times. So on top, I've got y2 minus y1. Those values are 6 minus 9 in the numerator. In the denominator, I'll be subtracting my x values. So I'll be doing x2 minus x1, 1 minus 4. Once I have those numbers plugged in, I'm just going to do the math. 6 minus 9 is a -3. 1 minus 4 is also -3. So step 2 is now complete. I've used the slope formula. Step 3 is to ask yourself, can this fraction be simplified? It equals 1. So yes, +1. So the negatives cancel. 3 divided by 3 gives us a +1. So if this slope is a +1, what will this line look like? What do you think this line will look like? Yeah, it'll be going up. That's what we can expect. So now I'm going to verify that by just graphing. I'm going to plot these 2 points, connect the dots, and make sure that they have a slope of 1. So going back over to the graph, if you're doing this by hand, you're just going to draw your x and your y here. And then you're going to just kind of need to draw tick marks in here. So we've got 1, 2, 3, 4. You only need to go up to 4 this way. And then vertically, we've got to get up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to have to make up a couple points. Okay, then I'm just going to plot these 2 points. The first is 4, 9. So over 4, up 9 will put me right about here. And then the point 1, 6 is over 1, up 6. That's going to put me right about here. I'm going to connect those 2 dots, forming a line. You can draw arrows on the ends to show that this is a continuous line. And then I'm going to verify this is a positive slope, so the line is going up. It's increasing just like I expected. But let's make sure that our slope is actually 1. What a slope of 1 means is that for every 1, now it's a whole number. So sometimes we want to think of slope as a fraction. We can rewrite this as 1 over 1. So what this should mean is that for every 1 I go up, I'm going to go over 1. I have a rise of 1 and a run of 1. So let's verify. If I go up 1, over 1, up 1, over 1, up 1, over 1, yes, those points are on the line. Now, just a disclaimer, if you're drawing your graph by hand and you're drawing your own points, your graph may be slightly off just because you're doing it by hand and it's not perfect. So as long as it's the same general shape and direction, that's fine. Your points may not line up exactly just because you drew it by hand. That's all. But yep, we have a slope of 1, and that's what the line would look like. So looking at number 9, we once again have 2 points. So if you're writing these by hand, make sure you write number 9 and you write the points 2, 1 and 8, 9. the first thing that I'm going to do is label my points. Here's point number 1. So I have x1, y1. And this is point number 2. So this is x2, y2. Step 1 is done. I'm ready to use my slope formula. M equals, I'm going to do y2 minus y1, drawing an arrow to make sure that I'm subtracting in the correct direction. 9 minus 1 on top, divided by x2 minus x1, which is 8 minus 2. Once I have those plugged in, I can go ahead and just do the math. 9 minus 1 is 8. 8 minus 2 is 6. For step 3, all I need to do is ask myself, can this be simplified? Both the top and bottom can be divided by, sorry, not 4, whoops. Both the top and bottom can be divided by 2. 8 divided by 2 is 4. 6 divided by 2 is 3. So our simplified fraction would be 4/3. Also, no one did it this way, but we do want to keep it as an improper fraction, not a mixed number, because you could write this as 1 and 1/3. But because we view slope as rise over run, we just want to use an improper fraction. So I have a slope of positive 4/3. What would you expect this line to look like? Positive, so moving, it would be increasing or going up. Specifically, we can expect to go up 4/3 from one point to the other. So let's verify that on our graph. My first point is 2, 1. 2, 3, 4, 5, 6, 7, 8. I need to be able to go over 8. And up 9. So if you're hand drawing your graph, you'll just need to write out those points. So my first point, 2, 1, I'm going to go over 2. Whoops. I'm going to go over 2, up 1. That's my first point. 8, 9, I'm going to go over 8, up 9, which puts me right about here. I'm going to connect those dots. Add my arrows to show that this is a continuous line. Then I'm just going to verify that my slope is correct. Up 4/3. So starting from my first point, I'm going to go up 1, 2, 3, 4, and over 1, 2, 3. Now, notice even mine, it's not perfectly lined up, and yours may be even worse. It might not be lined up really at all on that point because you're hand drawing your graph, and those mistakes can happen. But make sure that if you go up 4/3, you're somewhere close to the line. And then if we were to go up 4, 1, 2, 3, 4, over 3, 1, 2, 3 again, it would also be a point on this line. And this pattern would continue forever and ever, up 4, over 3, up 4, over 3. As long as we're following that pattern, we will find points on this line. But if you're ready for number 11, you can go ahead and write those points down. For number 11, we have 1, -2, and 6, 2. Step 1 is to label my points. This is point number 1. So I have x1, y1. This is point number 2. So I have x2, y2. Step 1 is done. Next, I'm going to plug these points into the slope formula. M, or slope, equals y2 minus y1. So in the numerator, I'm going to have 2 minus y1 is a -2. So I have 2 minus -2. They both need to be there. And then I have x2 minus x1, which is 6 minus 1. Remember, anytime we have a minus a negative like this, we can think of it as just plus. So 2 plus 2 on top gives me 4. 6 minus 1 on bottom gives me a 5. So the question here, when you're ready for it, is, can I simplify the fraction 4/5? All right, you are correct. 4/5 cannot simplify. So that's it. 4/5 is my slope. Keep in mind, this is a positive 4/5. So what would you expect this line to look like? Up. Awesome. This will be going up. So let's go ahead and plot these points. I need to get over to 2, 3, 4, 5, all the way up to 6. And then my y values range from -2 to 2. So if you're hand drawing your graph, those are the points you'll need to include. And then we can go ahead and plot them. The first point is 1, -2, which is down here. The second point is 6, +2, which is over here. We can connect those dots to form a line. Add our arrows on the end. And then I just want to verify my slope. If I have a slope of positive 4/5, it should mean that I'm going up 4/5 and following that pattern. So I'm just going to verify that. Am I going up 1, 2, 3, 4 and over 1, 2, 3, 4, 5? Yes, that is the pattern that works. Okay, so that's it for today as far as what we'll be doing together. All you need to do on your own is 8, 10, and 12. You're going to complete 8, 10, and 12 on your own. Your work should look just like mine. You need to show every step that I showed. You need to label your points, draw the arrows, graph, verify your slope, simplify your slope, all of those good things. And then you're going to take a nice, pretty picture of your skills practice page and submit on Canvas.